Hi guys, how are you? I hope you are well and fine and staying home safe. Okay, today our lesson is going to be about the integration, and I'm just going to cover the integration of the exponential functions. Okay, the rest I'm going to do them for another videos. So in this session, we will learn how to integrate exponential function, which is the e to the power something. Okay, and we will also need to know how to integrate them. So at this point, we've learned a lot about differentiating function and also need to know how to integrate them. What you need to remember is integration is the reverse of the differentiation. Okay, so when differentiation, if you remember, we did this last time. If y equals e to the power k of x, then dy over dx, it's going to be the e to the power k of x as it is multiplied by the derivative of x. So in this case, we have the derivative is k, which is just a number, yeah? And the integration for e to the power k of x dx, okay, it's going to be, again, same thing, e to the power k of x, but with the integration, we will divide by the derivative of the kx. So remember, in the differentiation, usually we multiply, but in the integration, we divide by the derivative of kx, derivative of x, sorry, plus c. So the c is the constant of the integration. Okay. Note this doesn't work for integrating general function as e to the power f of x. So that's just an example. For example, the integration of e to the power x squared dx is not equal to e to the power x squared divided by 2x plus c. So this one here, it's a special case. So the integration for it is not this, okay? So for now, we don't need to worry about it because we need to worry about questions like e to the power k of x. So in general, so integrating y equals e to the power kx will give us, like, this is the integration sign, yeah? This is the integration symbol, like this, you know? Well, that's not a very good one. Okay, and so this is the integration sign, e to the power kx dx equals e to the power kx divided by k, which is the derivative of kx here. Okay, the derivative of it is k, so in the integration we divide by this derivative, plus c, which is the constant of the integration. And it's important to write this c if you're integrating, if you are doing an integration without any limits. Okay, recall that if y equals ln f of x, yeah, remember this, we did it together about the differentiation. So if we have y equals ln f of x, then dy over dx is going to be the derivative of the function, yeah, which is f dash x divided by f of x. Yeah, remember when we have ln x, ln 2x, etc. So the derivative for ln a function of x is the derivative of the function divided by the function itself. And because integration is the opposite of the differentiation, therefore, if we have integration for a function, so this is the integration sign, yeah, so if we have integration of a function and the derivative of this function is, and the derivative of this function at the numerator, which is the top, dx, then the integration in that case is going to be ln f of x. The integration is going to be ln f of x. Okay, the same one at the bottom, plus c, which is the constant of the integration. Okay, remember again, if we have the integration for a function at the denominator, which is at the bottom, and the derivative of this function at the top, then the integration for this is going to be ln f of x plus c, if there is no limit in the integration, of course. Right, so we'll do an example here. We have the function and the derivative. If we have the function at the bottom, which is at the denominator, and the derivative of the function at the numerator, which is the top number, then the integration for it is going to be ln f of x plus c. So for example, we have 1 over x dx. What's the derivative of x? 1. Do we have it at the top? Yes. So we have f of x, which is x, and we have the derivative, which is 1 here. Then therefore the derivative of the integration of 1 over x dx is ln x plus c. Okay, let's see another example here. Right, another example, we have the integration of 2 over x. What's the derivative of x? 1. Do we have it at the top here? No. Right? So that means it is 2 ln x. Yeah? So this means, okay, right. Okay, so 2 over x dx equals 2 integration 1 over x dx. So we can take the 2 outside. Yes, can take the 2 from here, we put it outside, and then the integration now is 1 over x dx. We know 1 over x, the integration of 1 over x dx is ln x, so it's going to be 2 ln x plus c. Right, let's look at this example here. We have x squared, we have x squared plus 3x. Okay, so what's the derivative? So this is basically here is like, this is f of x, which is x squared plus 3x. What's the derivative of this? The derivative of f of x here is 2x plus 3. Yes? Do we have this at the top? Yes, we do. Yes, we do have this at the top. So this is the derivative of it. Yeah, which is same as this. Therefore, this means this is the derivative of it. Then in that case, I can say the answer is ln the f of x, ln f of x, which is the bottom one. So it's ln x squared plus 3x plus c, which is the constant of the integration. Okay, another example here, we have the integration of 1 over 3x dx. So that's basically its integration of f of x down here, which is 3x. Let's look at 3x, the function itself. What's the derivative of 3x? So the derivative of 3x is 3. Okay, do we have 3 at the top, at the numerator here? No. Yes? Therefore, we can say, we can take 1 over 3 outside as a number. Yeah? So this can be 1 over 3 outside, and then the integration of 1 over x dx. Okay, so now we can say it is 1 over 3 ln x plus c, which is the constant of the integration. Okay, so I'll just show you now the slide. Okay, so okay, right, this doesn't move. Sometimes technology doesn't work very well. Okay, right, so as I said, here we have the integration of 1 over 3x dx. We take the 1 over 3 outside the integration, and so this 1 over 3, it was inside the integration, we take it outside the integration, and now we have 1 over x dx inside the integration. And we already know 1 over x, the integration of 1 over x is ln x, so it is 1/3 ln x plus c, which is the constant of the integration. And this is the 1/3. Okay, perform the following integrals. Now we're going to do some, I'll go through these examples for you. So let's take this, right? The integration of e to the power 5x dx. Okay, so to do this, we said the integration of e to the power kx dx is, the rule is e to the power k of x as it is divided by k, the derivative of x, okay, plus c. So according to this, I'm going to work out the question here. So for this one, this question is going to be e to the power 5x divided by the derivative of 5x is 5 plus c. Okay, the second one here, I think this is same as the one we just did earlier. Anyway, so this is the function integration of the function f of x here, and what's the derivative of 2x squared minus 3x? So d over dx for x squared minus 3x equals 2x minus 3, which is at the top here already. So therefore, because we have the derivative here for this function at the bottom, therefore we can say this is a ln. So this is going to be ln. So this is the function, the derivative of the function, and this is going to be equal to ln so it's going to be ln the function ln f of x, which is ln x squared minus 3x plus c, which is the constant of the integration. Right, next one we have, okay, this integration here we have limits, it's definite integration. So it's same thing, all we need to do is like we just substitute the values of x by the numbers. So in this one, the integration is going to be e to the power 2x divided by the derivative of 2x, which is 2. Okay, and because this is a definite integration, it means it has limits, then we don't put plus c, but we'll put this, the limit, from 1 to 3. And now what we will do, we will substitute the value of each x by the numbers 3 and 1. So I'll show you now. Well, you already know this anyway, but just in case. So this is going to be e to the power 2 times 3 divided by 2 minus e to the power 2 times 1. We substitute the value of 1 divided by 2. And this is going to be e to the power 6 minus e to the power 2 divided by 2. And we'll find the answer. It's something, I'll show you in the slide. I don't remember what's the number. But just be aware that e to the power 6, e to the power 6 minus e to the power 2, it's not e to the power 4. It's not e to the power 4 because there is a subtraction between them. So we can't say e to the power 6 minus e to the power 2 is e to the power 4. That's wrong. Okay? Only if that was a division, then it will work. Like if that was e to the power 6 divided by e to the power 2, then we say yes, it can be e to the power 4. But because this is subtraction, which is minus, we can't do that. Okay, I just wanted to mention this to you. I just thought you might think about it this way, which is wrong. Don't do it. Okay. This is dangerous to do. Okay, so now I'm going to show you the answers here, right? So that was for the first one, which is we did e to the power 5 of x over 5 plus c. The second one, ln x squared minus 3x plus c. And the last one here, so these are the limits. And then we substitute the values of the limits, 2 times e to the power 2 times 3 over 2. And this is the answer if you just put this numbers in your calculator. Yeah. So to find e is not shift, it's alpha then pi, I think, alpha pi from your calculator. Anyway, it's in your calculator, it's e. Okay, so you do e to the power 6 minus e to the power 2 divided by 2. That will give you this answer. Right, so I think that's all for now, and I will go through some questions with you to practice solving the questions to practice the integration of the exponential function. And you have in your book as well some exercise. It's all related to the exponential function. Okay, bye, see you, take care of yourself, see you, bye bye.